We are going to discuss special products of binomials. There are two different special products. We have perfect square trinomials, where we have a plus b, and that's a perfect square because we're squaring that. And then we have a minus b, squaring that one. And then the other type of special product is the difference of squares. And so that's where you have one that looks like a plus b times a minus b equals a squared minus b squared. And so these are squares. A is squared and b is squared, and we're subtracting them, so that's our difference. Now, when you recognize one of these, you're going to be able to solve it pretty quickly by writing down this formula. Now, you should learn all three of these formulas. And in fact, if you are taking notes, you should pause the video and write down all the formulas on your screen. Now, let's look at why this works for a plus b squared. So if I have a plus b, and I square that, that is the same thing as doing a plus b times a plus b. When we square something, we're going to multiply it by itself. So we're going to multiply this by itself, a plus b times a plus b. Now, we can either take this a plus b and distribute it across the a and the b, or we can do the sort of distributing in reverse by doing the a times everything here plus the b times everything in here. So I'm going to do that method. So I have the a times a squared, and then I will multiply this a times the other term here, plus a times b. I can just write ab, and then I'm going to take the b and multiply it by everything in here. So I have the b times a. I can write it as ba or ab. It doesn't matter. I'm going to write it as ab because that's what I've already done with this term. Next, I'll take the b and I will multiply it by the other term in the second binomial, and I get b times b, which is b squared. Now, if I combine like terms, I have one ab and one ab here, so that gives me a squared plus 2ab plus b squared. So this is where we get this formula. A plus b squared equals that. Let's look at this one. We have a minus b squared. So a minus b squared equals this times itself. So it equals a minus b times a minus b. Now, can you think of what we would do next? See if you can multiply this out yourself, and then turn the video back on and see if you did it right. Okay, I'm going to do a times a, that's a squared, and then I'll multiply this a times a negative b. So a times negative b, that's like saying a squared minus ab, because a times negative b gives us a negative ab. So I can either write it as plus a negative ab or as just minus ab. Then I'm going to take this negative b, notice that's a negative b times a, and so that is just, I can write it as either minus ba or minus ab. I could have said plus a negative ab, and that would have been correct as well. Now I'm going to take this minus b and multiply it by the minus b here. So that's going to give me two negatives. If I multiply negative b and negative b, that's going to give me a positive, so that's b squared. That gives me a squared. Now this minus, remember this is a 1 if it doesn't have a coefficient, and this is a 1 if it doesn't have a coefficient. So I have minus 1ab and minus 1ab. That equals minus 2ab plus b squared. So this is where I get this second formula, a minus b squared. Now, what about this difference of squares? If I multiplied this out, if I took this a plus b times a minus b, then I would multiply these two, a squared. Now, a times negative b is minus ab. Now, let's look at this one. B times a, and I can say it as AB, and those are both positive, so this is plus AB. And then B times negative B is going to be minus B squared. Now, if I combine minus AB and plus AB, that's minus 1AB and plus 1AB, those disappear because they add up to equal 0. Now what I have left is a squared minus b squared. Now look, that's what I have in my formula. So if you recognize that you have a problem of one of these forms, you'll be able to use the formula as a shortcut for writing the special product.